Imagine a skyscraper that doesn't pierce the sky but emerges organically from the ground. A building that isn't just a structure but a living organism. Imagine buildings that adapt and evolve, changing shape and function according to the needs of their inhabitants and the environmental conditions. Just like trees in a forest, buildings that breathe, that grow and develop, that are part of the ecosystem. Is this a scene from a science fiction movie or a possible future for architecture? Can imagination become reality? This video explores the exciting idea of organic buildings and their potential to revolutionize the way we design and inhabit our world. How can we integrate nature into our architecture? Could biotechnology and genetic engineering hold the key to structures that grow like trees, that develop and adapt like living organisms, blurring the lines between the built and natural environments? Can we create cities that are as alive and dynamic as the forests that surround them? Let's discover together the possibilities of this new architecture. At the heart of this idea lies DNA, the fundamental building block of life. DNA is a molecule that contains the instructions organisms need to grow, survive, and reproduce. DNA carries the genetic code that determines the characteristics and behavior of all living organisms. Every cell in an organism contains the same DNA, which is unique to each individual. Scientists have made significant strides in understanding and manipulating DNA, allowing the development of new technologies and methods for studying and modifying genetic material, paving the way for synthetic biology. Synthetic biology is an interdisciplinary field that combines biology and engineering to design and build new biological entities. This field aims to design and construct new biological systems such as synthetic genes and cells that can perform specific functions, essentially programming organisms for specific purposes. The applications of synthetic biology are diverse and include medicine, agriculture, and environmental science. Could we harness the power of synthetic biology to grow buildings from genetically modified organisms? Imagine buildings that grow and self-repair, using living materials that adapt to their environment. Imagine planting a seed that sprouts into a house with its walls made of living, growing materials. This is the vision of bioarchitecture. Scientists envision buildings constructed from specially treated wood, capable of growing into predetermined shapes and sizes. This wood could be reinforced with biocement, a material produced by microorganisms that bind sand or gravel, offering a sustainable alternative to concrete. While the idea of living buildings is exciting, there are many challenges. Controlling the growth and shape of such structures would be a complex endeavor. External factors like weather, sunlight, and the availability of nutrients would require careful management. The structural integrity and safety of biobuildings demand rigorous testing and analysis. Furthermore, there are ethical implications of manipulating nature. Despite the challenges, the potential benefits of bioarchitecture are enticing. Imagine buildings that can self-repair, adapting to changing environmental conditions. Organic constructions could significantly reduce the carbon footprint of the construction industry, absorbing carbon dioxide as they grow. Imagine cities where buildings blend harmoniously with nature. Section 6. Rooted in potential current research and development. While still in its infancy, research into living architecture shows great promise. Scientists are exploring the use of fungal mycelium, a network of thread-like structures, as a building material. Mycelium can grow into various shapes and densities, offering strength and insulation properties. Other research focuses on genetically modifying plants to grow into specific shapes, potentially creating living walls and roofs. Section 7. Ethical considerations. Playing God or partnering with nature. The prospect of manipulating living organisms to construct our buildings raises profound ethical questions. Are we overstepping boundaries by manipulating nature for our own needs? What are the potential unintended consequences of introducing genetically modified organisms into our built environment? These are critical questions that require careful consideration and open public dialogue. Section 8. Branching out, future applications and possibilities. The potential applications of bioarchitecture extend far beyond traditional buildings. Imagine self-growing bridges, adaptable disaster shelters, even habitats on other planets. As our understanding of biology and engineering advances, the possibilities for living architecture become increasingly vast and transformative. Section 9. Conclusion. A budding revolution in architecture. The idea of buildings growing like trees may seem like science fiction today. Imagine a world where buildings are not just static objects, but living organisms that grow and adapt to their environment. This idea may seem far-fetched, but scientists and architects are working tirelessly to make it a reality. However, the rapid pace of scientific and technological advancement suggests that this vision may be closer than we think. New technologies such as biomimicry and nanotechnology are opening up new avenues for developing materials that can grow and self-repair. As we grapple with the challenges of climate change and resource depletion, the need for innovative solutions becomes ever more pressing. Bioarchitecture is not just a fantasy, but a necessity for our survival and well-being. Bioarchitecture offers an exciting path towards a more sustainable and harmonious future. Imagine cities where buildings are covered with plants that clean the air and produce oxygen, where walls can absorb and store energy from the sun. Will we one day inhabit cities where buildings breathe and evolve with us? Cities where nature and technology coexist harmoniously, creating an environment that is both beautiful and functional. Only time will tell, but the seeds of this architectural revolution are being sown today. New generations of architects and scientists are determined to create a world where architecture is not just an art, but a living, breathing entity. The seeds of this architectural revolution are being sown today. As new generations of architects and scientists work tirelessly, the vision of cities that grow and evolve with us becomes increasingly realistic. The revolution in architecture is here, and the future looks greener and more sustainable than ever.